Hello and welcome to part 2 of Claude doing structural steel design. How does Claude actually do steel design? This is example K9 from the AISC Steel Construction Manual Design Examples, version 16. On the right side you can watch Claude Opus 4.7 complete the design without any human intervention. On the left I will go through exactly what Claude did to get the design solution, which includes Claude queries the RAG database of AISC 36022. The required equations and tables are collected from the RAG output. The calculations are solved in a Python script. The report is prepared using JavaScript. So the problem involves a steel square hollow section column with a welded base plate of thickness 1 inch. The column rests on a concrete pad footing, and the end plate has holes for anchor rods. The design problem is to verify the strength given the applied loads. So Claude sets up a task list as seen in the progress column, identifying 6 tasks including search the AISC 36022 RAG for the base plate and concrete bearings provisions, verify loads and material properties, check the concrete foundation, check the steel plate, write the report and verify the calculations. So after setting this up, it begins querying the RAG database of the AISC 36022 steel structures specification. We can look at each of the queries to see how Claude gets the information required to solve the design problem. The first query is column bases bearing on concrete nominal bearing strength, so we can also see here what the RAG actually returns to the query. The first result contains the text of J8 column bases and bearing on concrete including equations. The other 5 results contain additional relevant sections. It is also demonstrated here that the tables from the specification are also cleanly returned. This highlights the strength and importance of using RAG for structural steel design. It is the most efficient way to give your AI agent, in this case Claude, the required information from the specification. Further RAG queries include Section J8 column bases concrete equation J81 J82 ASTM A500 grade CHSS specified minimum yield stress material properties flexural yielding rectangular plate plastic section modulus F11 phi load combinations LRFD ASD section B2 dead live F11 rectangular bars rectangles flexural strength yielding plastic moment MPZ. Okay, so now let's look at how Claude actually does the calculations. Basically, Claude now has a large text file of relevant sections, equations, and tables from the specification which tell it precisely the series of calculations required for the design. Claude writes a Python script which completes the calculations and checks so specified. We can see in the Python script Claude defines the section's properties, loads, and load combinations and prints the output at the end. The script then calculates the design capacities for the concrete and bearing and the bending of the steel base plate as required by the specification. The designs are then checked against the applied loads. This script gives us some insight as to why it is that Claude is so good at steel design calculations. Claude excels at coding and is one of best, if not the best AIs at coding tasks. Once Claude is provided with the process and equations, it is relatively simple mathematically to write the Python script and complete the calculations. We can see in the output of the Python script the details of the inputs, the calculated values, and the design outputs. These data are then used to prepare the report. Claude generates the report via JavaScript using the outputs of the calculations. Again, Claude excels at coding, and scripting the JavaScript is a relatively straightforward task. The report clearly identifies the sections and equations referenced from the steel specification. The detailed RAG results allowed the capacity calculations to be done strictly in accordance with the specification and allows easy compliance tracking and design checking by humans or other AIs. Okay, so how do I get these RAG databases? Set up your free structural steel design RAG to use with any AI LLM model. Step 1. Download the free RAG vector databases from steelcoldform.com. Step 2. Follow the instructions on the engineering RAG page to set up the API for running queries. Step 3. Connect your LLM of choice to your RAG API, allowing your AI agent to query your RAG as required. RAGDBs were created from free PDFs of the specification provided by AISC, and ANSI. All RAGDBs are provided free to promote the use of steel.